All right, we are going to go ahead and look at a funky little graph and see if we can't figure out how to graph it. So we get 3x squared minus 12x plus 12, okay, all over x squared minus 6x plus 9. And so the first thing I'm going to do is factor. So I notice that the denominator is a perfect square trinomial. And then I see that my numerator is just a little bit trickier in terms of factoring. So let's see if I can't go ahead and do this factoring. So I'm going to take the 3 out. Okay, and I notice that that's actually perfect square trinomial as well. So let's put this up here. Okay, and I'm not going to do the division because this is balanced, and I'm just going to leave it like that. And I'm just going to start listing out my characteristics. Okay, x equals 3. Even though the factor occurs twice, it's still just one vertical asymptote. Okay, this is y equals 3. 2, 0, even though, right, you can make a little note, multiplicity of 2, okay, and the y-intercept, 12 over 9 is 4/3. All right, let's put this on the graph. 1, 2, 3, 4, 5, 6. 2, 3. 1, 2, 3, 4, 5. Okay. Let's put our asymptotes on. Y equals 3. X equals 3. Okay. So I've got a 2, 0 and a 0, 4/3. Okay. And now I'm like, okay. I'm going to test my sections. Okay. Because if we're thinking about this multiplicity, okay, so I'm going to put a little clear sheet here, and we're just going to think about our multiplicities. If this has to be a double, it's got to bounce like this, okay, or it has to bounce like this. So if I look at this potential, somehow I have to get this graph to go back up towards my y-intercept and towards the horizontal asymptote. But you're not allowed to touch the x-axis anywhere except this point. So it's a little funky. Okay, so what if I make it bounce this way? Oh, that works out a lot better. And so that is one way to look at it, determining multiplicities. Okay, I'm going to do it with the regions, and I'm going to test it. Okay, so I've got this region here, which is x is less than 2. Then I've got between 2 and 3. And then I've got more than 3. Let's just figure out what happens. So I've got the factored form here. I'm just going to jot it down. So we've got 3 is positive. We have x minus 2, which is actually just squared. And then we've got x minus 3, which is actually squared. So that tells me that it's positive, 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 which means that it has to stay positive. Okay, well, because everything is squared over here, it's always gonna be positive. Oh, see that bounce? It's going right back up. Oh, the last section is gonna be all positive also. Okay, so let's connect the dots. So if we think earlier, it's got to be positive. So it has to come and bounce. Multiplicity plus the region has to be positive. And then over here, okay, you've got a couple choices, right? But if there's no reason to make it funky looking, then don't make it funky looking. Reasons are points. And so I'm just going to keep this graph above. Okay. Now, if you really wanted, you could test a point. So like x equals 4, just to give you a little bit of guidance. All right. So if I do that, I get some scratch paper to help me with my point. Okay. So let's just try plugging in 4. So we get 3 times 2 times 2 times 1 times 1. So that's 4. So we get 12. So it's way up here. All right. So that means that kind of helps me figure out that I'm just going to do this. If you want, you can plug in more points. It's up to you. Nice job. Look at that funky graph. It wasn't so bad. Now, let's see if we can't graph something that's got all the characteristics in it. I'm going to switch pages so I have lots of room. Okay. A little funky with everything. So I'm going to write it in factored form. Okay. X plus 3 minus 1. X minus 3. Right? X plus 2. X minus 3. Ooh, okay, so I am going to write it in the reduced format. Okay. All right. Vertical, horizontal, X, Y, and this time I'm going to add whole. Now it is balanced, right? See, quadratic, quadratic. So we get x equals negative 2, x equals 0, y equals 1. Negative 3, 0, 1, 0. Undefined, right? So none, because I can't divide by 0. And whole. Whole is x equals positive 3. So let's go ahead and find the y coordinate. So I'm plugging in to the reduced form. Okay, so we get 12 over 15. So that's 3/4. Let's put it on the graph. One, 2, 3, 4. 1, 2, 3, 4. 2, 3, 4. 2, 3, 4. All right. 0 and negative 2 for my asymptotes. And I've got a 1. Okay. Now we've got some points. Okay, 3, 1, 2, 3. Notice that this number is just less than 1. Okay. Now, I can think of my multiplicities, all right, and figure out what kind of shape might work best. Okay, I can also test the regions. So this is a multiplicity of 1, means it's going to have to go like this, okay, or it's going to have to go like this. Now, if it goes like this, somehow, right, the graph has to come back to the horizontal asymptote, but I can't touch the x-intercept again, so that is not going to work. If it goes like this, then I'm already headed towards, okay, Now I'm going to skip the middle section because I don't have anything to work with here. Okay, and I'm going to try this one. Now I've got to connect my points. And this is a multiplicity of 1. So it has to go straight through. That's it. That's how it has to go. Now let's say I wanted to do this. Okay, go this way. That would have to come back up. But you cannot touch the x-axis again, so that's not gonna work. So it has to go like this. Now let's try the middle. You have nothing to go off of, so I'm gonna plug in the value x equals -1 and to get a little bit of guidance here. So 2, -2. I'm plugging into the reduced form right here. So we get -4 over -1. So that's positive. Notice that you have a couple of choices. Okay, go like this. But you're not allowed to touch the x-axis, so that's a no-go. Up, up, up. Let's try again. What if you want to do like this? Nope, you can't touch the x-axis. The only x-intercepts are the ones that are plotted. All right. That kind of leaves me with the only option of this, because everything else would touch the x-axis. So this is your graph without regions and just considering multiplicities. You can do the regions, right? But sometimes it's easier to mix the two strategies together. So this outside, where the x-intercepts are, it's easier to consider multiplicities and general behavior. And then in this middle section, where I don't have any guidance, I'm going to try the regions. Okay, so we've got, I'm just going to write it here, x plus 3, x minus 1, x plus 2, x. So I'm going to try like -1 is positive, negative, positive, negative. So that makes it positive. And so I'm just going to, whoop. Notice I didn't plot the point this time because I didn't actually find the point. If you find the point, then you can label it. Have fun with your graphing adventure.